It happens in a chamber of absolute quiet. No sensation, no witness, just a drifting embryo and a waiting uterus separated by a microscopic distance. Everything up to this moment has unfolded perfectly. Fertilization, division, travel, timing. And then, the connection that should ignite pregnancy never forms. The embryo moves on, unanchored. Implantation fails, long before anyone knows it began. We tend to imagine pregnancy as a simple progression. Sperm meets egg, embryo reaches uterus, attachment occurs. But the reality is far more intricate and far more fragile. Implantation isn't automatic. It's a negotiation between two living systems that must align with impossible accuracy. A blastocyst arrives at the exact day it should. The uterine lining opens its short window of receptivity. Signals pass between them like whispered invitations. Yet even in the middle of this biological harmony, the question lingers. Why does a healthy-looking embryo drift past the place it was meant to anchor? Why does a receptive uterus suddenly close its gates? Why does implantation fail, even when every hormone and every cell seems perfectly timed? The answer is deeper than a single cause. Implantation requires molecular precision, immune cooperation, genetic clarity, and orchestration between tissues that have never encountered each other before. When even one element drifts out of rhythm, when timing misaligns, when communication falters, when the embryo signals dim, the connection dissolves. And most of these failures unfold invisibly, tucked inside the days between ovulation and an expected period. No symptoms, no clues, only a quiet ending the body absorbs and moves past, protecting itself with a decision made at the cellular level. This is not a story of fault. It is a story of complexity, of microscopic barriers, biological judgment, and the extraordinary precision required for life to begin. Let's go inside. Implantation is often described as a moment of attachment, but biologically, it is a dialogue, an exchange of signals between an embryo seeking a home and a uterus deciding whether to allow entry. And like any dialogue, it can break down at any point. To understand why implantation fails, we must zoom into the microscopic arena where embryo and endometrium attempt to synchronize. The journey begins with the blastocyst, now a hollow sphere of cells divided into two populations. On the inside sits the inner cell mass, which will eventually form the embryo. On the outside, the trophectoderm forms a protective shell, destined to become the placenta. Its job in these early hours is not nourishment, but communication. It must signal to the uterus, "I'm viable, I'm ready, I can continue." As progesterone rises after ovulation, the uterine lining enters its receptive phase. This is not a passive softening, but a complex transformation driven by hormones, immune cells, and microenvironmental shifts. Glands thicken, blood flow increases, adhesion molecules appear on the epithelial surface, integrins, selectins, and LIF, leukemia inhibitory factor, among others. Together, they form the molecular welcome mat the blastocyst depends on. But this window is narrow, just 2 to 4 days. A deviation of even 12 to 24 hours can mean the difference between implantation and failure. If the embryo arrives too early, the lining is not receptive. Arrive too late, and it has already closed. Inside the uterus, immune cells undergo their own choreography. Uterine NK cells, vastly different from circulating NK cells, shift into a tolerant pro-growth state. They help remodel maternal blood vessels, preparing them to supply the developing placenta. Macrophages coordinate the inflammatory balance, ensuring the environment stays supportive rather than defensive. This shift toward tolerance is one of reproduction's most delicate tasks, because the embryo carries paternal genes, making it, biologically, a partial foreign body. If this immune shift does not occur correctly, the uterus may mount subtle defenses. Not violent rejection, most women feel nothing, but a quiet failure to support attachment. Cytokines shift, adhesion molecules diminish. The embryo never receives the invitation it needs. On the embryo side, another set of challenges unfolds. Most implantation failures can be traced to genetic issues, a silent error in chromosome number or structure. A blastocyst may look healthy under the microscope, but at the genomic level, it sends weak or inconsistent signals. The uterus, constantly sampling molecular cues, detects the discrepancy. Rather than risk supporting an embryo incapable of progression, it simply refuses to anchor it. This is not malfunction, it is protection. Even a genetically normal embryo can fail if its trophectoderm does not mature properly. In the hours before implantation, trophectoderm cells must differentiate into cytotrophoblast and syncytiotrophoblast layers. The latter is essential, a fused, invasive tissue designed to burrow through the uterine epithelium, dissolve extracellular matrices, and establish the earliest form of placental contact. If this layer forms too weakly or too slowly, invasion stalls. The blastocyst remains at the surface, unable to proceed. The uterine lining itself can introduce obstacles. Low progesterone may prevent full transformation of the endometrium. Thin lining reduces blood flow and decreases the density of adhesion molecules. Scar tissue, fibroids, or polyps may distort the architecture just enough to block entry or alter vascular supply. Spiral arteries, crucial for early nourishment, may fail to dilate adequately, depriving the embryo of essential oxygen gradients. Even stress can influence this process. Elevated cortisol subtly reshapes the hormonal and immune environment, shortening the implantation window. Thyroid hormones, too, are deeply involved in preparing the endometrium. Imbalances can shift timing or reduce receptivity. And then there is communication, the most intangible and easily disrupted element. The embryo releases factors like HCG and IL-1 to signal its presence. The uterus responds with LIF, integrins, and prostaglandins. This molecular conversation must be coherent. Any misalignment, wrong timing, insufficient signal strength, misinterpreted cues halts the dialogue. When implantation fails, it often happens at the moment of attempted contact. The blastocyst opposes itself against the uterine surface, waiting for adhesion molecules to bind. If they are absent, muted, or out of rhythm, the embryo cannot anchor. It drifts. The uterus continues cycling toward menstruation, and the earliest phase of pregnancy ends unnoticed. This entire process, genetic screening, hormonal alignment, immune balancing, vascular preparation, unfolds without a single conscious sensation. It is the body making decisions beneath awareness, choosing safety, viability, and precision over chance. Implantation doesn't fail because the system is fragile. It fails because the system is protective. And yet, when all of these elements align, timing, genetics, immune tolerance, blood flow, molecular dialogue, the connection forms with astonishing speed. The blastocyst adheres, invades, and for the first time, maternal and embryonic tissues merge. This meeting marks the true beginning of pregnancy. But when even one step goes off rhythm, the connection dissolves quietly. A microscopic misalignment. A silent non-decision. A biological pause before another cycle begins. Implantation failure is one of the quietest biological dialogues, and one of the most revealing. It unfolds without pain, without sensation, without any outward sign that two living systems have attempted to connect and then stepped back. Yet within that silence lies a portrait of how exquisitely the body regulates the beginning of life. When a blastocyst fails to anchor, it isn't simply a missed opportunity. It is a decision shaped by layers of biological intelligence. The uterus is not passive. It is discerning. It evaluates signals, monitors inflammation, adjusts blood flow, and senses genetic viability through cues we cannot see. When something feels misaligned, timing, genetics, immunity, structure, it chooses protection over risk. The embryo, for its part, does the same. If its cellular machinery falters, if division slows, if signaling weakens, it cannot progress, and the dialogue dissolves. These early failures are often invisible, yet they speak to the body's commitment to stability. Pregnancy requires precision, so exact that even a small deviation can shift the balance. And instead of forcing a connection, the body quietly resets, preparing the environment for another attempt. There is a profound humility in this process. It reminds us that conception is not a single triumphant moment, but a sequence of alignments, timed windows, synchronized signaling, cooperative immunity, and structural readiness. It is a choreography in which both partners must be prepared, responsive, and in rhythm. And when implantation succeeds, it does so because this delicate alignment holds, because the embryo's signals resonate clearly, because the uterus opens its window at the perfect moment, because tissues recognize each other not as strangers, but as partners in a shared biological endeavor. Implantation failure, then, is not a malfunction. It is the body's way of safeguarding potential, a quiet verdict of protection, a pause rather than a denial. In understanding these early endings, we gain a deeper appreciation for the moments when connection does occur, when the microscopic universe of the uterus opens, when a blastocyst anchors, when the first bond of pregnancy forms.